The idea of something changing is pretty simple, but the concept can be expanded to a very big level, or to a very advanced level. That's what I'll be talking about today. So when something changes, there's a reaction. So we have the reactants, the things that go in, the reaction where the stuff changes, and then the products, the stuff that comes out. I hope this concept is pretty simple for everyone to understand. So let's start at the big picture. So a physical change is when the substance chemically stays the same, only its physical appearance or being is changing. So if I got a glass of water and dumped it in an ice tray and froze them into a bunch of ice cubes, it would be a physical change because it's still water. I've just changed its phase of matter. And if I got all of those ice cubes and melted them back again, that's still a physical change. And if I got the glass of water and just left it outside and let it evaporate, that's still a physical change, just goes into a gaseous form. There are also a lot of other physical changes you can learn about, but the list is really big. So, moving on, going to a bit smaller scale, when something changes chemically, a chemical change. So, a chemical change is when a substance changes chemically. So, we still have the atoms that we have are still the same, but the substances are different. As an example, plants use photosynthesis. They get carbon dioxide and water, and take that. Sunlight helps them gain enough energy, and then they react producing glucose and water. At this rate, we are now going from the basic level to a more advanced level. Atomic changes, or nuclear reactions. These reactions are spontaneous, and a bunch of them happen at the same time, and are highly radioactive. For example, a lithium atom reacts with a hydrogen 2 atom and produces a highly unstable beryllium atom, which then immediately decays into 2 alpha particles. I really hope the drawing that I draw on this slide will help explain this. Going to an even smaller level, we reach the subatomic level. So subatomic changes are when these subatomic particles themselves change. For example, a neutron can decay into a proton, an electron, and an anti-electron neutrino. We've gone from the very big to the very small. Well, physical changes might not seem big to you, but they are the biggest on this tier, relatively. So, the thing is that regularly, when you have a physical change, you can change it back. Chemical changes, however, most of them are irreversible, or at least will take some difficulty to reverse. Atomic and subatomic changes, have fun with that. And also, whenever there's a reaction, the matter must be conserved. What goes in must come out. So that means the amount of matter, the charge, and a bunch of other basic fundamental properties. Some things can change, others can't. So, thank you for watching this video. If you liked it, leave a like. If you have any ideas for future videos, put them in the comments, or if you want to critique me, feel free to put them in the comments. I'll pop the next link to the next video sometime sooner or later when the next video comes out. And I hope you enjoyed this. Thanks.